Hello, everybody, and welcome to another Q&A Corner presented by High-Tech U. If this is your first time dropping by, welcome to Q&A Corner. We are so excited to have you. This is our first Q&A Corner of the week, but it's such an exciting way to start our week with a pretty amazing guest here from the University of Victoria Faculty of Engineering. Who I'm going to introduce you to in just a minute, but you obviously would have seen when you jumped on the stream, Dr. Heather Buckley. But before we introduce Dr. Buckley, who's standing by to say hello to everybody and talk a little bit about her journey into the world of science and engineering and technology, just want to give you a rundown on how things are going to work. So, first things first, if you are here, we're so happy to have you, and we're so happy that you are excited about learning about what the journey into a career in STEM is like. As we're going through today, if you're catching us live here on Twitch, we have got a chat which should be over there or down there, maybe up there. I'm not sure where it'll be for you, but we've got our chat, and you are welcome to use that chat as we're going to throw in your questions that you have. As we go through, I'm going to be monitoring the chat, there to say hello, share some links and cool stuff, but feel free to throw it in there. If you're really not quite sure if you want to do that and you've got another place that you'd like to throw your questions, you can go onto our website, hightechu.ca, and there's a form on our Q&A Corner event that you can submit a question via email, and we'll make sure that gets over to our guest as well. Realizing that I didn't introduce myself, my name is Andrew. I'm the co-founder of High-Tech U here at the beautiful University of Victoria. We are part of the Faculty of Engineering based in the Department of Electrical and Computer Engineering. With all of that said and our introduction to the show, I'm so pleased to introduce you to our spectacular, amazing, awesome guest for today, Dr. Heather Buckley. How's it going, Heather? Well, I've got to unmute you. Oh, there we go. I took away all the power. There we go.
You did take away all my power, but it's great to see you. Great to be here, Andrew.
I gotta say, I'm so excited whenever I get to connect with somebody that's here at the University of Victoria, because I like to think that we're only like a room or two away and we're doing a live stream like this. But I know that are you on campus right now, or are you working from home still?
Today I'm working from home. My research group is back on campus, back in the lab, being careful, wearing their masks. But I am mostly working remotely for the moment, but still here in Victoria on Lekwungen territory.
That's fantastic. Well, Heather, welcome. Thank you again so much. I was saying just before the stream to everybody who's tuning in, Heather and I have had the great fortune of working together in different things that I've done here at the university over the years. But this is, I think, the first time that from the High-Tech U hat, that there's really been an opportunity to connect you with the amazing world of our folks that are connected with High-Tech U as well.
Yeah, absolutely. I've had the great opportunity to meet some of the students who've been involved in person on campus, but this is the first time getting to talk with the broader community. So hi, everyone.
Awesome. So I always do a couple of quick things at the very beginning, which I never say anything about to people that are on the stream, but really the reason that I do the first thing is so that I can make sure everything is going well, and I load up the stream on the side. But Heather, while you introduce yourself, I'm going to do some background studio things to make sure things are working. And I'm going to spin it over so that you are front and center on the screen, just to kind of share a little bit about yourself. Because obviously people know from the bio, but let's be honest, not everybody reads bios. So for those that didn't read the bio, a little bit about you.
Yeah, sure thing. Thanks, Andrew. So hi, everyone. My name is Heather Buckley. As Andrew said, I'm an assistant professor in civil engineering here at the University of Victoria on beautiful Vancouver Island. I know a lot of you are close by, but some of you are farther away. So welcome, and thanks for joining us this afternoon. A bit about me. I am originally from Alberta. I grew up in the foothills of the Rocky Mountains, in and amongst all of the different waters that flow there, a lot less water than we have here. I came out to the West Coast after high school to study chemistry at the University of British Columbia, our neighbors across the water there. Had a great time there. worked with an amazing undergraduate and master's advisor, Dr. Jennifer Love, and then headed south and spent 8.5 years in California. So in California, I did my PhD also in chemistry. And while I was there, I got really involved in green chemistry. We can talk a bit more about green chemistry if folks are interested in that, basically trying to do chemistry in ways that are safer for people and the planet. And with that, got involved in some work developing roofing in low-income communities in India. Got involved in water treatment, looking at how to provide safe drinking water to communities with reduced access to that. And that was the work that brought me here to the University of Victoria, where I joined Canada's greenest civil engineering program. And so here at UVic, I've got a fantastic research group. We've got 11 members in our research group right now, coming from all over the world and all kinds of different backgrounds. We have people who've studied microbiology, people who've studied software and electrical engineering, people who've studied mechanical engineering, civil engineering, chemistry, toxicology. A whole range of backgrounds find their home in our lab, and we make sensors to detect contaminants in drinking water. And we work on biofouling. We work on preventing microbes from growing in water when we don't want them to. And recently, we also work on monitoring how much COVID there is in your poop. So I'm happy to talk more about that as well if people are interested. So how's that for an introduction, Andrew?
That is amazing. So many like rich tidbits there that I'm super excited to explore, and I know our viewers will be too. And if you are just on the stream, welcome. You are here, Q&A Corner. We're here with Heather Buckley, professor here at the University of Victoria in the Civil Engineering department. If you don't know what civil engineering is, that's totally okay. You probably know what chemistry is. Maybe you have come to hate it. We're going to convince you that it is awesome and super applicable across the board for so many cool things. And so maybe that's a good place actually to jump in and start. Is you talked about this idea of green, and obviously green is like a big conversation now. Everybody says they're green, they're trying to be more green. What is green chemistry all about?
Yeah, that's a great question, Andrew, because it is very easy to say, oh, this is green, and use that as a buzzword. And it can mean a lot of different things. It can refer to being more friendly to the environment. It can refer to something being tied to money. I mean, especially in the US, their money's all green. Imagine a country where all of the money is the same color. It's crazy.
Yeah.
Thankfully, we have multicolored money here. For me and for the field of green engineering and green chemistry, what I mean when I say that is that we're designing products and materials and processes that are inherently safer for people and for the environment. And so that's a mixture of different things. That includes thinking about the people who are using it. So something in its use phase, like when you go and buy a bottle of shampoo, to know that the chemicals that are in that shampoo, because all shampoo has chemicals in it. If your shampoo says it's chemical free, they're lying to you. But if something says it's got chemicals in it that are safer for you, it's this kind of thing that you're okay with putting on your body because it's not going to give you cancer in 30 years. We're also thinking about the folks who are manufacturing it in the first place, because if you clean your toilet once every not quite often enough, maybe those noxious chemicals aren't such a big deal to you. But if you work in the cleaning industry, or if you work manufacturing these chemicals, you're exposed to them every day, and that's really important. And it's also thinking about where we get things from. If we're using renewable resources that don't deplete the planet, and if we're generating chemicals that when we're done using them, when we release them out into the world, are they sticking around? Are they causing problems for fish and algae and other organisms in our waterways? Or are they breaking down into benign, safe things that just go off and turn into carbon dioxide and water, and or things that are safe for microbes to munch on and continue their life cycle?
See, that is a much better definition of what green actually is than I think a lot of people would necessarily have. So how does that? Well, I mean, I guess you can kind of put the map pieces together about how that connects with like COVID and poo, but obviously that's a super relevant topic right now. Is like detection of COVID. I heard about this fecal matter detection stuff that was being used really heavily in the nation's capital in Ottawa. I didn't realize that it was happening here, and let alone that you were sort of behind it. So where did that come from? What is that all about?
So that's been a really neat collaboration for our group because it kind of sits at the intersection of my two areas of knowledge. And I think as folks are thinking about, where do I want to be when I grow up? What kind of science do I want to do? The reality, or what kind of engineering do I want to do? The reality is that new projects come at you out of left field all the time. And so I actually had a colleague who does molecular biology, so who analyzes microbes and other organisms and looks at their DNA, approach me and say, well, this has just started happening. I think folks in Ottawa were doing it. There were a couple of other groups doing it, but back last July, there was almost nobody working on this, but recognizing that we could be taking sewage, so taking the samples that are coming from our wastewater treatment plants, so basically taking your poop and bringing it into the lab. We sterilize it so that it's not as icky, and so that it's not possible for anyone who's working with it to catch COVID. And then from there, we run that through a process where we separate out the DNA from everything else. We count how much there is, and that gives us a correlation of, okay, how much COVID is there in the wastewater? So how much is there in the population?
Interesting. So you say these projects kind of come. Did you ever see yourself? Because obviously a lot of our viewers that are on the stream, their parents or teachers or students. Did you see yourself when you were like in high school or early university? Did you ever see yourself that you would be professionally being paid to examine poo?
I did not. So when that's a great question, though. And anyone out there who is already thinking along those lines, good for you. That's amazing. It's a pretty amazing project. A little smelly at times, but not the worst. I did actually, when I was in high school, I was looking particularly in going into medicine. And I realized in looking back, what inspired me about that was that I enjoyed science. I loved my biology and chemistry and physics classes. And I saw, and my math as well, honestly, I'm a big nerd. I loved my math class in high school, but partly because I had great teachers. But I really saw medicine as a way that I could use science to help people and help my community. And in the environment I grew up in, I wasn't as aware of research as a path forward. And I wasn't as aware as well. I mean, a lot of things like with civil engineering, the ways that engineers are helping people are often very hidden. And so what was visible to me was, oh, I like science. I want to help people. I should be a doctor. I got into university, and it wasn't so much that I stopped wanting to be a doctor as I started wanting to do other things more. I got really excited about molecules, and the ways that we could design molecules to do very specific things we wanted them to do. And that led me down this path of working on molecules for fuel cells and now molecules for a lot of other things. And then, zooming back out from molecules to think about bigger systems.
So I'm curious, do you think that that's sometimes a problem for folks that are in high school? Is there still, and I think it's still today is the same thing. There's like this perception of career opportunities. There's like, you can be a doctor or a lawyer or a teacher, and those are like the career pathways. Do you think, like, particularly for folks that are interested in STEM, that problem exists, that there's so many opportunities and yet they're so limited of what people are aware of?
I think that's absolutely a challenge. I think there's a lot of careers that people don't realize the ways that their skills can be used. Like if you're really good at physics and you've got a knack with computers, learn a computer language. There's so many different things you can do with that. There's so many things in electrical engineering space, or I mean, even in trade spaces, there's so much technical work going on around electronics and electronic engineering. And that can be through a university path, that can be through a college or a trade school path. There are a lot of really neat technical careers that use all of these science and engineering skills, and all of them are really critical to helping people lead better lives. So yeah, exploring those, knowing what's out there, or honestly, getting to first year university or college and not having any idea what you're going to be studying, just knowing like, hey, I'm really excited about science and engineering. It's a totally reasonable place to start. You don't need, when you're 18, 19, 20 years old, to have already figured out what you're going to be doing when you're 50. Like, I don't know what I'm going to be doing when I'm 50, and I'm significantly older than 18 now.
Yeah, it's true. I think like, and especially for our viewers that are out there and our viewers that tend to watch these, like if they're in grade 10, 11, 12, they've sort of been on this path of like, I'm going to do this thing, and all the courses that they're doing are to like get them to that very specific place. And I think so often, and I'm sure you see this as well, because you teach students here at the university that are young, that are coming in and they're like, I think, and even you said, I want to do this thing, but then you change your mind. You're like, I don't necessarily want it. And that's totally okay. It's okay to change as you're going through and learn more things.
Absolutely. I think that's a good thing to do. I think that's actually one of the features of a good scientist or a good engineer, is the ability to gather new information and change your mind based on that information. I think if we get stuck in one way of thinking, that can be really challenging and really, really problematic. But if we learn new things and go, oh, that's a possibility I've never considered, and we really seriously think about it, that's how science and engineering progress.
That's a super interesting take as well on like the value of the university experience as like a petri dish to learn and grow and do these things. I don't know if actually anybody's quite put that scientific experiment angle on it before, so I really like that. I think that's, for anybody who's out there that's a budding scientist, like just come to university for the very least, not only to study science but to be part of it and learn and grow.
Absolutely. Yeah.
So I'm curious, and again, if you're just jumping on this stream, welcome. You're here, Q&A Corner, presented by High-Tech U here at the University of Victoria. We are here with Dr. Heather Buckley, Assistant Professor in the Civil Engineering Department here at UVic. We are talking all things, we're talking all things, but I need to get us back. We're talking all things sort of STEM careers, journeys into this world, tips and advice and all the fun stuff. So if you've got questions, throw them in the chat. If you're catching this on YouTube, please throw your questions in the comments below, and we will definitely be checking those to make sure that those questions get over there. But I want to kind of shift a little bit while we're waiting for more questions to come in, into I mean, it's very relevant right now, but you touched on something when you were talking about yourself earlier and the diversity that exists in your lab in particular. And you focused on like sort of different backgrounds of engineers and scientists and all the rest of these things. But I mean, the conversation around diversity in STEM is obviously a big one right now. You could just have all civil engineers or all chemists that are in your lab doing these things. Why do you choose to have a more diverse audience in the work that you do? What's the value that diversity brings to your team?
Yeah, well, as one of my colleagues who's at York University says, disciplinary boundaries are so 20th century. He will say that very glibly, but it's really true. What we need in STEM, if we're going to tackle these big challenges, if we're going to solve the global water crisis, if we're going to address the challenges of the COVID pandemic, and so many other problems, and just particularly anything with an environmental justice focus in it, we really need people who come from all kinds of backgrounds in our research. And I highlighted particularly those disciplinary backgrounds, but I would also really highlight differences in lived experiences, people who've grown up in big cities, people who've grown up in rural contexts, folks who've grown up in single parent households. Everyone brings in different experiences, people who've grown up on reservation, people who've grown up in an apartment in town. We need all of those different experiences, because one of the things that's really crucial about science and engineering is, as much as we have a scientific method that's very objective, the place where we start is from the questions that we ask. And those questions are asked by people. And having different people asking questions means that you get more challenges to the kinds of questions you're asking, and you end up just asking better questions. And then once you've asked all those different questions, you're in the place to say, okay, which of these questions is important and which ones are we going to tackle?
So true. So do you see that maybe same appreciation? Just do students recognize that when you see them coming into a course? I mean, I tend I guess you kind of think when you're in high school, especially, and I know a lot of our students that are out there, they are the science kids, right? They're the ones that are in the chemistry and the physics, and they're in the math class, and like they're destined for it. Do you start to see students recognizing the value of diverse backgrounds and all the rest of this in the classes that you teach and in the work that you do, or is it still kind of a struggle for them to kind of recognize why that diversity is so important?
I think it's still something that we're working on. I definitely see it more as I get into upper level classes, as we shift to more project-based work. I think it becomes more obvious because we start asking these really integrated questions. We do a course in civil engineering that I teach on trace metal contaminants in drinking water. And as we start tackling those, you start realizing that there's biology challenges and that there's civil engineering challenges, but there's also access challenges. If you're designing something for a rural community, what it means to be able to get up the road in winter to a community that's 4 hours north of Prince George is very different than what it means to get up the road from Victoria to Saanich. Those are all very different spaces that people need to be able to think in. And by that point, one of the things I really love in our program is our students all go through co-op. And so they come in with these cooperative work placement experiences. So by the time I'm seeing students in third year and fourth year, they've all gone out and they've all worked in different places. And it's so common to have people come into my classroom where I'm actually the one being the learner because they've had all of these experiences in their workplace where they have areas of expertise that I've never been exposed to. And I think that's really where I see students starting to understand the value of those diversities of experiences is when they get to step up in a team and be a leader and an expert in something it's very easy when you have an area of knowledge and you work within it to be like, oh, well, everyone knows all of this. But if you've gone and spent an entire summer coding in Python to program a robot that can do water sampling, you're going to have a very different set of experiences than somebody who has gone and spent a summer working up in northern BC doing tree planting. And both of those are really neat, really engaged science and engineering related experiences. But if you bring those two people into a room, the different stories they'll tell and the different tools that they can share with each other in order to collaborate are just incredible.
Wow. See, I gotta say, Heather, every time that we chat, I'm always just like, yes, all of those things that you are saying are so perfect for students to hear. And I'm so happy that students are hearing them now and that they're getting out there. So if you're listening to this, this is like, these are gold. These are nuggets of wisdom that will live on in perpetuity. So I'm curious, in kind of down the line of, how the students that you're seeing in upper year differ and how they're kind of starting to recognize what they bring to the table. Do you think that there is kind of still the what's the phrase? Do you still find that there's a perception that students have this sort of it's not inferiority complex, it's what's the word where you don't you think like you're not supposed to be there? It's like a really big
imposter syndrome.
Imposter. Like, do you see imposter syndrome in like some of these really talented students that you're working with that are kind of uncomfortable and not believing they should be where they are?
Oh, absolutely. And I'll full disclosure and transparency. I experience imposter syndrome myself. I mean, I work with such talented, amazing people. I mean, I have sometimes even experienced it next to my students. I have less of a coding background than many of my peers, and reminding myself that the fact that I lean on my research team to do the coding and modeling and computational work, and that I bring a different set of skills to the table and that we're complementary. I mean, that's really where the power is, but it is intimidating, to walk into something and to just have to be vulnerable and have to trust others to be bringing those skills and to not have to be everything. But yeah, I see that with our students, and I have a lot of conversations with our students. I mean, especially with our female students, I think there is a tendency for women to be told that it's not normal for them to be scientists and not normal for them to be engineers. And I think that's something that is is quickly changing, and I'm excited to see it changing because yes, you belong here. Um, and it's really challenging to recognize that you don't have to be perfect in order to be awesome and in order to belong. And everyone you see who's at steps ahead of you along the way always seems like they know exactly what they're doing. That's because the parts where they're struggling aren't visible. That high school teacher or that professor as you go along who you are taking quantum mechanics from, it's entirely possible that they failed their first year biology class, or maybe they did okay in it, but mostly because they had a best friend who was really good at biology and they studied together while they taught that friend quantum mechanics. And so they found each other and they found teams and got through like that. So I think that's a really important thing to remember is you don't have to do this on your own. You're not supposed to do this on your own. The point is not to be all of the things by yourself. The point is that you have strengths that you bring to the table and you find your people scientifically, socially, professionally, in all of those contexts, you find your people and you collaborate. And between the two or the three or the many of you, that's where all of those skills come in.
Amazing. Oh, you touched on so many things, so many directions that I want to go with that. But if you're out there in the stream, everybody's really quiet. This is good. And they're like listening so intently. So if you got a question, throw it into the chat right over there or down there or up there or maybe one of those ways. If you're here on YouTube, you can throw your question down below. But just ask some questions that we've got. And I'm going to check my email while I ask this next question, which is actually a very relevant one because Heather reminded me earlier that and I remembered yesterday, but I didn't realize that it was there was a whole that there was some special things happening the whole week. Yesterday was International Day of Women, so I think there's a really important conversation to have there. Starting off by saying I come to this from a very privileged point of this conversation, being a straight cis white man of a good socioeconomic class. Like I've got a lot of pieces that are going for me, and so I can't necessarily bring a lot of perspective, but I'm curious, Heather, you're in engineering, which is a predominantly male profession. So are you seeing changes recently? Has it been slow? Like what's kind of your perspective on I guess the issue of a lack of diversity, particularly in terms of women in the field of engineering?
Yeah, that's a great question, Andrew. And I also, in entering in this conversation, want to acknowledge my own privilege that I also am coming at this. Like I am a woman in STEM, but I am a cis woman. I'm white. I was raised by parents who had some university education, and a lot of those opportunities that have made this path one that is not as hard for me as it is for a lot of other people. And one thing that I think is really exciting and empowering that I'm seeing is things are getting better for women in STEM, and there's starting to be folks who are researching and studying and analyzing that and seeing that we are getting better representation. We still have a long way to go, but the representation is getting better, that opportunities for women in STEM to have peer-to-peer mentorship and to have role models above them. I feel really fortunate. My master's advisor was an early career woman of 15, 16 years ago, who was at the stage in her career that I am now, who took me on as a graduate student. And having that mentorship really created a solid foundation for me and normalized the idea that I could be that kind of rock star. I could be the person that I saw going before me, which was phenomenal. And one of the big things that I think is now starting, but we're decades behind on the conversation, is recognizing all of the intersectionalities, recognizing that we need to be creating better spaces for racialized students, for minorities, for Indigenous and Black students in particular, for LGBTQI students, and recognizing all of those different many identities that disappear into that acronym, but are many, many different things. And yeah, making these spaces safe spaces and realizing that just having numbers there isn't enough, but making sure that these are spaces that are safe, that people have resources to access, that people have people in senior positions who they feel like they can talk to. And the data that is coming in on the way things have been getting better for women is providing evidence to support continuing putting resources. And by resources, I mean hiring staff, I mean putting money into having folks creating programs and creating mentorship groups and creating safe spaces on campus for diverse students. Because really what we want to be achieving is a place where the engineering campus at the undergraduate level, and as we continue to go on, looks as diverse and amazing as the population of Canada and of the global population. We really need, as I said before, those diverse voices inherently make the scientific and the engineering professions better. And so bringing those folks in and continuing to challenging norms is just such a core piece of what's happening right now. And we've got an amazing new dean coming in, Mina Hurfar. I'm so excited to have the chance to work with her. She's super enthusiastic and she's keen to collaborate. She's keen to hire students as researchers. And I think that's a really bright opportunity for the future of engineering at UVic.
Awesome. Thanks so much, Heather. That was such a well thought out and articulated answer. So we got a question. We actually have somebody that's in the chat right now that's throwing up a question. So welcome, Sixers fan, and also all of our other guests who are kind of sitting behind, that are just kind of waiting. They're not sure if they want to ask a question. We're here to answer your questions. This is an opportunity for you to talk to somebody that's here to answer your questions. So Sixers fan has dropped by, and they let us know that they said, I want to do aerospace engineering when I get older, but then their question specifically is like, what subjects should I focus on if I want to get into and be successful in engineering?
Ooh, that's a great question. I'm going to give you an answer that is going to surprise you, and that answer is, if you're wanting to go into aerospace engineering, you're probably already excited about your physics and your math, and maybe your chemistry, maybe your biology. The place where you really need to focus, and you're not going to like this answer, is English. Being able to be an excellent engineering and science communicator is a really big differentiator right now, and is going to continue being a differentiator as our disciplines become more and more mixed together, and as we work with people from so many different technical backgrounds. Being able to write and speak and communicate clearly about the really cool work that you're doing is what's going to create opportunities for you. Because if you can explain to somebody who's not right in your field what you're doing and why it's awesome, you will spark their interest. They're going to want to come work on what you're doing with you and support you in doing it. If you're talking to the government, they're going to want to give you money to do what you want to do, which is always nice, because at the end of the day, all of this cool research equipment, rockets are expensive to build, so you need a little bit of grant money to do it. So yeah, really focus on getting good critical reviews of your work in English, and editing with your peers, and just learning to be a really good critical self-reflective editor of your own work.
Awesome. So there's a little bit of a lag between kind of what we're putting out there and the questions. So Sixers fan, if you got some follow-up questions from that, feel free to throw them in the chat. But while we're kind of on that note of being able to explain things, and we've kind of touched on a little bit, but there's a lot of people that are out there that hear about engineering and they say, oh yeah, I want to be an engineer. I find a lot of those are like high school students that have connections with engineering, but a lot of people, particularly those that are coming to it from a different place, they don't see themselves as an engineer. Even myself, and again, sort of recognizing that place of privilege. When I was in high school, I was in like rural, small town Ontario, and nobody went and studied engineering. Everybody, like the one kid that went to study engineering had like a 99% average. He was like that super dedicated to it. And so I always had this assumption that engineering is only for like those super amazingly smart physics and math people. Those are the only people that this is for. But what is kind of at the core of what engineering is all about? Is it math and physics, or is there something else?
Oh, that's a great question. So I'm going to put a question back to you, Andrew. So if you grew up in Northern Ontario, you almost certainly did more than your fair share of shoveling snow when you were in high school, right?
Yeah, so it wasn't Northern Ontario, but we'll consider it Northern. Let's pretend as though it was. No, but yes, I definitely did a lot of snow shoveling when I was in high school.
All right. So as a teenager shoveling snow, you pretty quickly, especially if you're either getting paid to do it or you want to go back inside and play video games, or go tobogganing with your friends or whatever it is, you figure out the most efficient ways to move snow off of the surface that you're required to clear and make sure that it doesn't just all slide back down on again. So as you're doing that, you're doing engineering, you're doing structural engineering, because you are thinking about you're thinking about angle of repose, you're thinking about what's going to happen, thinking about, so the geotechnical engineering, what's going to happen to this snow when it stabilizes? Is it going to run everywhere? What angles can I get away with scooping it? How does it change depending on what kind of snowfall this was? March snow is totally different than October snow. So if you are doing any of those things where you are moving stuff or putting stuff together or building things or staring at something in your life and going, oh, I wish this was designed differently. I can actually say the moment that I became aware of engineering design being something that required people with different perspectives coming in, was actually a really funny moment when I was in high school, and I was at a place where people went to go sailing, and so it was a space that was mostly men, and I was in the bathroom, and I discovered that in the bathroom stalls they didn't have any little garbage bins in the bathroom stall. And for any of the women who are on the call, you'll immediately know exactly why you need little garbage bins in the bathroom stall. For the men on the call, I'll let you think about why you might need that and why, as a man, you might not have thought about needing that in there. And I went, wow, this space was clearly set up by a man. If they had had a female perspective in designing this room would have been set up differently.
It's so true, right? It's little things that if you don't have the experience, I think you said it earlier, like that idea of diversity of experience goes a long way, right? If you've never experienced that thing, then you're never going to put it into the solutions that you create.
Yeah. And so if you've ever had that experience in a space where you went, I wish this was set up differently, or you were trying to get a coffee machine to work and you were like, this button's in a really dumb place. Who would put a button there? If you think that way about things, you're well primed to be an engineer. If you've ever been trying to use a piece of software and you're like, oh, why is this so awkwardly set up? Gee, I wish I could go into the command line and fix that. And oh, why won't it let me? Or why is it behind this wall or whatever? Any of those ways of thinking about things. Or, if you're out in the environment and you see that trails have been built in a particular way and you go, oh, the way this trail is, like, there's these newts that want to get down to the water and it's very exposed for them. Then you're thinking in an environmental engineering space. Like all of these things are great forerunners to being a good engineer. Having high grades, having high marks is not by any means the fundamental piece of it. And some of the best research students who've come through my research group have been people who have pretty mediocre marks. And if I'd looked first at their transcript and used that to judge them, I might not have accepted them in. But instead, I looked first at what are they excited about, what makes them passionate. And that was the deciding factor. And they've then come into our research group and just done amazing things in the lab.
I love that. So it's not all about grades, everybody. Despite what your high school teachers may tell you, it is not all about the grades. It's about following your passion.
You need to get a high enough grade to get into the program you want.
True.
So I'm not. This is not Dr. Buckley telling you to stop studying. But the things you're passionate about are what is really important there.
Yeah, totally. So Sixers fan, thanks for the follow-up question. It's a little bit out of the scope of our chat now, but if you go to hightechu.ca, you can find a link and some more information. We also have a Q&A corner from last season where we had a cybersecurity person on, and you can actually throw a comment in there and they will respond to it. Yeah, it's a good question. And either way, the idea of communication still applies. So just as like a heads up. So Sixers fan was just saying, I'm also interested potentially in cybersecurity. What do I need to enhance that? And I think all of these pieces, if you talk to anybody who's hiring cybersecurity analysts, engineers, everybody wants somebody that has those professional soft skills. It's not all about the hard, like you can do the math, you can do these things. It's about the ability to communicate it out.
Yeah, I would agree with that. Like, I'm completely unqualified to answer questions about cybersecurity, but it's a super important, really interesting skill set that's developing. And so and communication is a big part of that as well. But being able to explain to people why the tools you're developing are important, why those tools will make their life better, that applies in cybersecurity and across a broad spectrum of other areas.
So this kind of goes into a right direction, and I feel like Sixers fan, you've started us off in like a nice direction on like student and preparation for post-secondary. So Heather, you see lots of students in your okay. That's interesting. That's a good question. So I'll jump back because Sixers has thrown a question in there. So the question was, what kind of a job is so we're focused on aerospace engineering, and just like full context, Sixers fan. We're neither of us are aerospace engineers, but the question was, is it a tactile, auditory, or visual job? Like, is that the kind of, how would you consider it? And I think it's all of them, I would say.
Yeah, I think there's a lot of diversity within those kinds of jobs. I would caution you against the idea of too strongly identifying as one of those three types of learners, because I know that the idea of the three categories of learners has been widely debunked by studies. Like, you'll find areas that are your strengths, but everyone has capacities in all three of those. So that's actually a really interesting area of psychology research, which is, again, totally outside of my knowledge, almost as far outside of my knowledge as cybersecurity. But yeah, although I do think a lot about methods in teaching and learning, and that definitely applies into careers as well. I mean, if you go into aerospace engineering, you could end up anywhere from, applying to be part of Canada's astronaut corps. Dr. Jenny Seide, who's one of our newest astronauts, is someone who I grew up with. So when I didn't make it to the final round in that astronaut application, but I saw she was in there, I was so excited. Everyone from home was rooting for Jenny. And that job is going to be a very, very immersive, literally, they throw you in tanks of water and make you jump off of high bridges experience. But you're in all of those spaces. I mean, you can be physically building robots. I've got friends who've worked on the Mars rovers, and that can range anything from doing the software engineering coding for the Mars rovers within that aerospace context. That can mean doing rocket design and doing combustion simulations and combustion experiments with different fuel combinations. That can mean physically building the next generation of the Canadarm. That's going to have higher dexterity, because our robotic arm capacities have just evolved so much since the early days. I don't know if anyone saw the Boston Dynamics dancing robots back around Valentine's Day, but having been involved through close friends and colleagues in the early competition in that space, where all of the videos you would see 20 years ago or even 10 years ago were being accelerated because the robots moved so slowly and it was boring. See dancing robots, it's just like, this is so cool. So I think in that aerospace area or any other area of engineering, but yeah, thinking specifically about aerospace, since that's what our typer asked about, yeah, it's really going to be all three of those. And being able to have the auditory skills as well, like the listening, input, output, all of that communication, being able to understand what people are telling you and assimilate and process that information, always going to be super important.
Amazing. So that robot thing, actually, so I was going to go a different direction because it was very on point, and we'll jump back there. It's a good question. Man, I love it when like the questions just keep coming. So there's another question, but I want to talk about something before I forget. So speaking of dancing robots, obviously your area, you're a chemist, you're a civil engineer, you're an associate director at the university, but also you are more than just your job. And I'm super curious if you're willing to share about the work that you do on like kinetic sculptures and your work as an artist as well.
Yeah, absolutely. So I've got a picture behind me, and something that may look interesting to folks. It's hard to tell exactly what it is from there, but I can also give you a zoomed out version of it here in the background. Choose virtual background. Where did that go? Oh yeah, there we are. So that's the full size sculpture.
Oh, very cool.
So I have had the really good fortune with an amazing group of people from all over the world, a lot of whom are based in the San Francisco Bay Area, but not all. We're everywhere around the world. We have this amazing. Speaking of interdisciplinary collaborations, we've got software engineers on the team. We've got artists on the team. We've got robotics experts. We've got musicians, and then artists who are really like antique collectors who are very tuned into getting period pieces right, and folks who have some background and knowledge on indigenous traditions in the region in Nevada where we do our art. I've been involved in a number of interactive art sculptures, including the one you see behind us, which is called Fire Ancestor. And so I was part of a big team of people, led by several of my friends, building the Fire Ancestor, which is an evocation of, I don't know if anyone has ever seen on the edge of a forest fire, you'll see dust devils that spin out, and those are on fire. And in the Navajo tradition, those are a fire ancestor. And I feel like I'm definitely telling other people's stories now, in that I don't come from a Navajo background, but my best understanding of the story is that in times of fire and change, that these are fire ancestors will come and watch over what is happening. And so it's a very sacred, very special thing to see a fire ancestor. And yeah, just working with a really amazing team of people and getting to bring all our technical expertise. One of the big things I brought to this project, for anyone who's done ideal gases yet in high school, you may be familiar with the formula PV equals nRT. Pressure times volume equals number of moles times the ideal gas constant times temperature. It turns out, to get a giant sculpture like this, what you can't see is that this sculpture spins quite quickly, and it shoots bursts of fire from random places all over it. And in order to do that properly, you need to have pressure regulation, and you need to manage the temperature of your gas canisters so that your pressure doesn't drop. And so you actually have to design this whole system to be accounting for the pressure drops that happen when gas is coming out, and the temperature drops that will accompany that, so that it doesn't ever ask, so that it's programmed. So you interface with the software engineer to make sure it's programmed in a way that it can't ever ask for too much gas at once. And in doing that, we've then taken all of these really neat engineering and science tools. And as I said, it goes all the way back to that high school formula. PV equals nRT is a good enough equation for working with propane, for doing this kind of work, to be able to make something that is beautiful, that is inspiring, and that is safe. We have a perimeter around it to keep folks back, but we can have it out in the middle of the desert without without having, really advanced safety features. I always keep a fire extinguisher on my hip when it's running, but beyond that, it's pretty good.
I love it. I was actually like searching for a video so we could pull it up on the stream, but I'll maybe search a little bit more. But Sixers fan is here, and there's so many more questions, and it looks like in late middle school, so just about to go into high school. So that's why there's so many questions about like what to do to prepare for engineering. So another question that came up here, and I'm gonna kind of reframe it a little bit because I think the classrooms change. But like in your mind, what does an ideal like STEM engineering learning environment look like for what would it look like for a student? So the specific question is like, what does a STEM classroom look like? And I think that's a broad question. So maybe what would I mean, you create these in how you teach. What does your ideal kind of STEM teaching classroom look like?
Yeah, that's a great question. So one of the things that I really love seeing in our classroom is a lot of time for interactivity. And that's one thing that's actually been really interesting, that's been highlighted working online this past year or so. So I've been teaching online for almost exactly a full year now. You'll all remember about a year ago when you went away for spring break and then just didn't come back. So at the university, we basically went immediately into an online environment. And the first couple of weeks of it, I'll admit, were pretty rough. But then Andrew was one of the phenomenal people actually who helped me bring a lot of my course material online. And one of the things that let us do is take the parts where the instructors or the teachers just standing up at the front talking to you, put that all in videos beforehand. So you can watch those videos before you come to class. You've seen the preliminary work, you've already done a bit of reading. And then the time that we spend in the classroom, instead of it being just listening to somebody talk to you all day, is time that's spent in groups, doing group problem solving, doing group design challenges. And because you're in that environment, you've got the mentorship of your professor or your instructor and the teaching assistants who are there to kind of come around, listen to what your group's doing and share ideas. When my classroom's going exactly the way I want it, it's very, very loud. There's a half dozen whiteboards around the room with 5 or 6 people gathered around each of them. And they're working in multicolors, drawing things, coming up with designs, and asking questions that I don't know the answer to. And that, speaking of imposter syndrome, it can be a little intimidating. And I just love being in that environment where the students are asking questions that I don't know the answer to because they're generating questions that are at the edge of knowledge.
I love that. So in the time that you were explaining that, which is awesome, I was actually able to, hold on, I'm gonna pull up hosting guest 1. So I was actually able to find, is this it? This looks
That's
like what it is. Yeah, so this
yeah, I dropped you a link in the chat that should have a video in it as well.
Yeah, so this is it, hey?
Yep.
Yeah, so I'm gonna share that out in the chat too, the link that that Heather sent me. So if you want to check it out, but yeah, that's an idea of like things that you can do with STEM and with engineering that you might not normally think of as having a focus on, like being an engineering thing. So let me just pull up. Oh, awesome! I'm gonna pull this up. I'm gonna show this link on there. Let's close that and go back over here. I've learned to be a pro with multiple screens, but my computer's in a bad mood today, and so I've been streaming all day, and it's like, don't stream anymore. I don't want you to stream anymore.
I think you need to feed it chocolate.
I think I do need to feed it chocolate, or just like anything that is not me making it stream in front of lots of people. So let's see if I can get that loaded up. Oh, weird. Oh, that's right, because you can't copy and paste. I totally forgot about that. Thank you, Zoom features. Oh, very cool. Oh, that's so... This might actually be the same video. Sorry, nobody that's on the stream can actually see what I'm looking at right now, but I've got up the link that you just sent me. And then, is it the video at the bottom? Oh yeah, so I'm pretty sure it's like the same video that we were just watching.
Yeah, there's another one on there too.
Oh, that's so cool. Oh, so we got a couple of minutes left. So we're about 5 to 5. And I always want to leave a moment for kind of the super salient like messaging for people. But there is we've got time for one more question, and it's going to come from our favorite in the chat, which was what were you and we talked about this earlier, but kind of just revisiting it for a second. So what was kind of your interest in on what you wanted to do in post-secondary when you were in high school?
Yeah, so when I was in high school, my big picture interest was that I was planning to go to med school, and I was going to become a pilot, and then I was going to become the surgeon on the International Space Station.
That is very specific.
Yeah, so that was where everything was headed. And the thing I realized in the process of figuring out where to go with that as an undergraduate was there wasn't one right program to go into. And that really the best thing to do was to study a program where I liked most of the courses I was taking and where I was excited to keep taking them. And so I found myself I enjoyed the biology I was taking, I enjoyed the physics, but I found myself just really, really fascinated by the chemistry and by the molecules and the ways that things changed color. This business where things are shooting fire and making bright colors is kind of a natural outpouring of where my interests led me in university. So I started out in a first-year science program, doing general science in a small program at UBC. From there, I went on and just chemistry was so cool. I took chemistry, and then it just kept being cool. And so I kept taking more of it. And then that has continued to wind this circuitous path where I realized that going into medicine wasn't the best path for me. There was nothing wrong with it, but there was this really cool opportunity to make molecules. And really, that was much like mechanical engineering is designing devices and robots and many other things in mechanical engineering. Chemistry allowed me to design molecules.
Thanks, Heather. So I'll answer this last question, and then we'll do kind of our final thing that I always like to do to stress out every guest before we go. So Sixers fan, nobody else on the stream today, but that's a great question. That's a good segue into kind of saying what's going on. So all week, except for tomorrow, so really for Thursday and Friday, we do have more guests. So Thursday, we're going to have at 5:30, our special guest Layla Abelseth, who's a UVic biomedical engineering alumni, also a co-founder of Axolotl Biosciences. I think I pronounced that right. So a co-founder of a biotechnology startup is going to be here. Friday, Yamila Franco, co-founder of, is a biology grad from UVic, and entomology as well, but co-founder of Nyoka Design Lab, and Afro Hub Market is going to be on the stream on Friday at 4:30. So we're not back tomorrow, but we will be back on Thursday and Friday. So make sure to tune in. So with all that said, now time for the stressful question. That is kind of also the trailer that I use for all of these streams. So if you could encapsulate your most salient message for a student that is that's looking to go into engineering or science, and they're not quite sure and they just need some advice, what would be the advice that you would give to that student that's in high school looking towards their future in STEM?
Ooh, that is a great question, Andrew. I think the advice I would give is, if you're excited about science and engineering, then you belong in science and engineering. So you belong here. Don't be afraid of not having perfect marks in everything. Don't be afraid that there's a subject that's hard for you. Be excited about the parts that you are good at. Be excited about the parts that inspire you, and know that there is such a large umbrella of science and engineering that if you come and you study it, you will find the place that is the right spot for you. So come join us.
Amazing. See, I love these cut to perfect trailers, and I like the extra stress seems to bring out the best results from everybody. Thank you so much, Heather. That was amazing. The hour literally just kind of disappeared as we were chatting. You and I, and chatting with Sixers fan. And I'm sure all the other viewers, I'm always amazed because I only see some viewers that are in the chat, but we always have a lot of other viewers that are just kind of lurking and checking out what's going on. So for all of those folks that have been just kind of hanging out in the background, thanks for being here. Thanks for listening. Thanks for checking out Q&A Corner. It's been awesome hanging out. Heather, it's been such a pleasure to connect and to chat a little bit about your journey and some cool stuff that you're doing. Thanks for being here.
Yeah, thanks so much for hosting me, Andrew, and thanks to all of our viewers for joining us. And even if you're sitting quietly listening in this one, you heard something that excites you, go tell a friend about it.
Yeah, and if you are tuning in at its very end, if you're a Sixers fan and you want to know more about what's going on at High Tech U, or if you're just there and you want to find out more, you can check us out on YouTube. This whole video is going to be uploaded there probably tomorrow, and you'll be able to put your questions in the comments down below, and I'll make sure that those get to Heather, and you can throw any questions in there really if you want to, and we got lots of other great streams for some of other guests that are in there. If you want to learn more about High Tech U, our link is at the very bottom of the screen there, hightechu.ca. I've also thrown it in the chat, and you'll be able to find it in the comments below on YouTube. But aside from that, Heather, thank you so much again for being here. To all of our viewers, thank you so much for being here as well on Q&A Corner, presented by High Tech U, an initiative of the University of Victoria's Faculty of Engineering based in the Department of Electrical and Computer Engineering. I hope that we'll see you again on Thursday.